Welcome to week 3 of Devtoberfest. My name is Nora Fontaine. I'm a developer advocate at SAP. Today's Thursday, which means it's Data Analytics and AI Day. We have 2 sessions today, one now, about large language models and how to enhance them with your own documents. And later today at 4 Central European Summertime, we have one on AI ethics. So make sure you join the group in the SAP community so that you can be part of the contest, and you want to be part of the contest because we have a lot of cool prizes again this year. One is an all-expense paid trip to California to the SAP Newport Beach office. And another one, for example, is a call with Jürgen Müller, which I think is also really cool. So make sure you sign up for the contest and make sure you also do all the validation tutorials of the sessions you follow. I'm going to post the validation tutorial link in the chat later and also in the comments. You will find a lot of more fun activities and tutorials in the Devtoberfest group to earn a lot more points, so make sure to check it out. What did I forget? So as I said, the session today is about enhancing large language models. And I'm really excited about this session because Karim Mohraz is our speaker today. And I'm going to tell you a little story. Do you know when you meet a person and they make an impression on you, but they have absolutely no idea who you are or how they met you? And I think that's how I met Karim, because I was a machine learning consultant at SAP like years ago, I don't know, like 7 years ago or something. And I went to a Leonardo training in Waldorf, and Karim was there to explain convolutional neural networks. And I think they're really complicated networks usually, but he explained it in a way that everyone in the room immediately knew how they worked, what they were used for. Everyone understood the architecture, and I was just mind blown. I thought, if I ever have to explain CNNs to anyone, I'm going to do it like that. So when large language models popped up, I was like, who's better to explain it to us than Karim? So I'm really happy that he's here today. And I'm going to start with a little bit of a clarification, because I feel like when I talked about the session, many people mixed up what ChatGPT is, what GPT is, what a large language model is, and no one actually knew what a transformer was. So I'm just going to quickly clarify it before we start the session so that there's no confusion while we talk about large language models and AI and whatnot. So ChatGPT is an application on top of GPT, any GPT model. GPT is just a name for a model that the company OpenAI trained. So there's GPT-3, GPT-4, whatever version. And that's just the name of the model. The model is a large language model. A large language model is called that way because it's a gigantic model, because it was trained on a lot of data and it has a lot of nodes, kind of like in your brain. That's why it's so large. ChatGPT, on the other hand, is just the application to talk to this model, just to make it feel like a chatbot, but it's not the model itself. And then the large language model, the underlying neural network architecture, is a transformer model. Why is that cool? Because a transformer model makes it possible to parallelize the training. So it basically gets a huge amount of text, and it can positionally encode the words in the text so that it can train on a large corpus of text at the same time. Whereas the models we had before, like RNNs, would kind of forget the beginning of the text while they were training on it. So transformers are cool because they can learn on a lot more data than RNNs could at the same time. Yeah, I think that hopefully clarified it and didn't confuse everyone more. But Karim, just go ahead, introduce yourself and start your session so we can learn how to use LLMs.
Does it start? Okay, I hope you can see the PowerPoint now. So, yep. Nora, thank you very much for the introduction. I'm a developer in the SAP AI Core platform. And today I want to talk about a use case called question answering, where large language models like ChatGPT have made a great impact. So usually the large language models are trained on public available data, like Wikipedia. And if you ask domain-specific knowledge, which the network has not been trained on or had not have access on this data, the answers are of the large language model or LLM is not satisfying. So the question is, how can one enhance and extend this knowledge with domain-specific knowledge? There are currently two approaches for this. One is fine-tuning, which is the classic retraining we know from neural networks, where you provide new data and while training, the weights of the network are adapted. For large language models, this is very costly and time-consuming. Some large language models need up to 4 GPUs in parallel. So not everybody can do the fine-tuning. Although I think in the future, in the next couple of months, we will see fine-tuning coming up as a new method to train large language models. The current approach would be to take smaller models than the huge ChatGPT and train them on the domain-specific knowledge and be on par with a huge model like ChatGPT. But today I want to focus on the second approach. So you have heard about prompt engineering. Prompt engineering means you add more context to your question that you send to the LLM. And with this context info, you push or nudge the large language model to give you a better answer. However, you don't want to do this manually. So an idea would be to automatically create these prompts and enhance your questions with this context info. And there is an approach called retrieval augmented generation, or in short, RAG. So here you see a picture, what is happening here. So what we do is first, we take all our documents about our domain. These can be text documents of any form. It could be PDF, standard text, Word documents, even HTML pages can be scanned today and the text extracted automatically. And what we want to do is to vectorize these texts and put them into vector store, which then is our knowledge base. The idea is to vectorize them using a language model itself, because when these documents are vectorized by the embeddings of a language model, it is easy to do a semantic search by just comparing the vectors of the question to the vectors stored in the context knowledge base. Thus, we are doing a semantic search and not only a string search. This is very important. And so when you when you type in your questions, we look for similar documents to the content of your question, and then automatically feed them in addition to your question into the prompt before sending it to the large language model in order to get better answers. So I want to show you a demo how this retrieval augmented generation is achieved. I'm using a library called GPT4All in order to run these larger language models locally on my machine. So obviously I cannot run ChatGPT because it is not available as a model, but there are a couple of free to use and open source models out there which we can use to play around. But finally, if we want to do the real thing to get the best answers, we should use one of the bigger models, and there we should switch to a hyperscaler or to dedicated GPU machines. I also don't have a dedicated GPU on my machine, so this is running CPU based, and you will see that for playing around, this is perfectly fine. As a use case, I wanted to use something where people can relate to. So I used from Wikipedia a database with movie plots. And the idea is to search for a relatively unknown movie and to see how we can improve the answer by injecting context info from our database. So now I will switch over to the Jupyter Notebook. And what you can see here, so what I wanted also to tell you that after the stream, we will provide all the material in a link to a repo where you can download and run this code the same way I'm showing it to you. So what I have installed on my machine is GPT-4All, which is this library to run these large language models locally. And in that addition, I'm making use of a library called LangChain. LangChain is very useful because there are so many models out there from different vendors with different APIs and different characteristics. And LangChain helps to work with all these separate models in a unified way. So they have achieved that we can use high-level methods. They call them chains. In reality, these chains are just pipelines which do all the pre-processing and massaging of the data such that you just input the question, the text question, and all the rest is done in the background. And for us users, it is really easy to deal with this. So I'm using here a model called Llama 2 with 7 billion weights. This is a kind of a medium network, we can say. And I already downloaded it to the cache, so I can load it here locally. If you are doing it the first time, you can uncomment this line, so this will download it for you. And so I can just put in my question and run this chain that you can see here, LLM chain run the question. And I'm asking about a movie called A Touch of Zen. And here you can see the first answer of the large language model, which is the plain language model without any context info, without any other prompt than getting the relevant infos. That's all the model gets, and the name of the movie. And the model claims that this movie is a Taiwanese film from the year 2001, created by this guy. This is the director. But this is not the truth. So here you can see that the model is making up something because it does not have access to the right knowledge. And we call this thing hallucination. Here you can see the info from Wikipedia, which is inside our database and has been vectorized. So A Touch of Zen was released in 1971, and the director is King Ho. So how can we make now the language model to give us this information rather than the one that is generated here? So here we are going to use our retrieval augmented generation approach. The text, as you could see, has been already extracted all into a folder here from this CSV. And I already have vectorized it, so we are not going to run through all this stuff. But here also you can see some statistics about the movie in this database. So let me enlarge this a little bit. So what you can see here, that it is 35Ks movie plots inside the database from the whole 1900 century until 2017. And there are mostly American films, some British films, and from other countries. So as I said before, all the extraction and vectorization has been done. As you can see here, I'm using local vector store, and vector database called Facebook AI similarity scoring. This is a very performant and compact small database which I can use locally. And I've already persisted the vector store into my disk. So the only thing I have to do is to load it from disk so I can every time use it. It took me 1 hour to create this database for these 35,000 movie plots. So and this is loaded in less than a minute. So now what I'm going to do is I'm going to ask the same question again. Tell me about the movie A Touch of Zen, and let's see what the large language model is retrieving for me. And as I said, our context info is in this database, and we are going to query similar documents from this vector store. There is one issue when I run this with on the vector store, as the plots are, some of the plots are very large, and I get this error. 2048 is the input size for this Llama 2 model with 7 billion weights. So the input size is too small. If we are dealing with ChatGPT and other state-of-the-art large language models, the input size is around 16,000 K to 32,000 K. A new model from the vendor Anthropic called Claude is already released, which can even take 100 K input size. So here, for running it locally, I have to do a small trick to reduce the input size to 2048. And what I'm doing here is I'm using, again, from LangChain, a compression retriever. This contextual compression retriever chain or pipeline or method summarizes and compresses the text that we retrieve from the database semantically. So it's not like cutting off some parts, but it's trying to semantically do a summarization. And what I've done here is that after running it, we can see that it actually finds the plot that I have shown to you previously in our database, and it gives us a plot summary about the movie. In addition, because it's a similarity search, the same method, which is called get relevant documents, also finds other documents which might be related to some keywords which you find here. For example, Zen, you can find it in Zenobia. Or maybe this film talks about Buddhism and the way of Zen, and that's why it is also similar. Now, the nice thing is, after retrieving, the nice thing about large language model is you can even add information which is not useful or superfluous, and still the large language model is able to concentrate, to focus on the right information and extract the answer from the right text. And here I'm going to now take my compressed context. As said before, I have to do this only because I'm running this locally. So if we would have a GPU-based and bigger model, we would not need to do this because the input size would be big enough. Now I'm running the question again. The question is, tell me about the movie A Touch of Zen. All this context info is added to the question in the background. So it is an automatic programmatic extraction of the context, which is added to the prompt. And see here, now the answer of the LLM has drastically improved. We see the right director, King Hu, who was created the movie in 1971, and we see a summary of the plot. And this is much different from our first answer, which stated it is a 2001 released film by another director. So as you can see, this retrieval augmented generation approach that we used here helps a lot to enhance the knowledge of a large language model with domain-specific knowledge. So the next question would be, how can we run such a large language model in a productive setting? And here, just a second. Yeah, here I wanted to show you the product that I'm working on, which is called SAP AI Core. This is the AI platform created in SAP and can be used both by internal products of SAP and also by customers. And the nice thing about it is, if we start from the bottom, you can extract knowledge from SAP systems, or even you can provide your own data via external cloud storage on the hyperscaler where we run this AI Core platform. This is the AI Core platform is a Kubernetes based product, and it is fully managed by us. The good thing is also you can use any AI framework or machine learning framework to run your own code, because we wrap it into Docker containers and then run them on this platform. We have two main features. One is we call them AI workflows, but basically these are the ability, the feature to train neural networks and to save the model and use the data that you provide from a system down here. And after training the model, you can save the model again in the storage of the platform and use it then for serving. But you don't have to train it on the platform. You can also train your model elsewhere and just upload the trained model file and do the serving on the AI Core platform. One other advantage of this platform is also the scaling ability. So we are using open source, proven state-of-the-art modules like Kserve, which allows for scaling up and down on demand of these models. And also this allows the ability to do pay-per-use. In addition, we have some own development and tooling and libraries and SDKs where you can programmatically connect to this platform. And we have a tool called AI Launchpad. It's a browser-based tool for monitoring, operating, and managing the lifecycle of your AI models. And finally, you could, because this is just an API-based access to the models that you serve here, then you can integrate the responses of any models, for example, such a large language model, because we will be able to host and run the large language models also on this platform. You will be able to integrate them into existing SAP applications. So this is what we do, and provide AI-infused products to our customers. Or you can have your own application. It could be an app, a web app, which takes the inference URL of the model and thus can integrate the responses of an AI model into your own custom application. So that's all the story I wanted to talk today. please watch out for the TechEd announcement, which are done very shortly. And watch out for the announcement about large language models, which will be hosted on this platform. So thank you very much.
Thank you, Karim. I learned a lot, certainly. There are some questions in the chat, and because you just mentioned TechEd, yeah, make sure you sign up for TechEd virtually or anything, because first of all, you also earn points in the Devtoberfest contest by signing up for TechEd. And also, as Karim said, there will be some AI announcements, obviously. Yeah, so let's get to some of the questions. I already tried to answer a little bit, so you don't have that much, but maybe you can answer the first question first. Someone asked if ChatGPT is learning from the user input.
That's a good question. So no, it is not learning, because while sending the user input to the network, it is just an inference. So the input is run through the network structure and the answer is retrieved. In training, you would have a feedback path. In order, you need the right answer and the answer that is created, and then the weights are adapted in order to push the network into the right answer. But this is not happening when you just send a question to a large language model like ChatGPT.
Okay, then next question. What does vector store mean in retrieval augmented generation?
So let me go back to the slide. So the vector store is basically a representation of all my documents. So if I have domain-specific knowledge, in this case, it would be one document per movie, which is text. But in order to send this text into a large language model, we need to tokenize it. We need to convert it into a vector representation of the text. And this vector store is the converted movie plots into a vector representation. And the database used here, which I earlier used, FAIS, Facebook AI Similarity Search database. This is what I call a vector store, or generally is referred to as a vector store.
Thank you. One more question is occurred on costs of running AI, but I don't know anything about it because I'm not in the sales area. Do you know anything about it? Otherwise, we skip the question.
No, I can give you some hints. So also, if everyone can create a private access to ChatGPT, and also you can have a paid access, right? And right now, Microsoft is running and hosting ChatGPT on their own servers. But just imagining that it is at least 4 GPUs with 80 gigabytes of RAM for each GPU. You can imagine that the cost per hour of running such a model is maybe $10 to $50 per hour, so maybe around $10 per hour, so it is costly. And therefore, it is important that you use the network of a size that is matching your use case. And also on the AI Core platform, we provide this pay-per-use. So only when you send your inference request, then you are charged for the time it takes to find a response. And then later on, there are no other costs involved.
Okay, so again, watch out for TechEd to know how you can use large language models with SAP. Then there was another question. Or actually, that was a question I got before, and I just saved it for you because I thought it was very interesting. How can we tell it's a hallucination?
Mm-hmm. Yeah, I mean, if you're a domain expert, if you're or compare the answer to the real facts, either in Wikipedia or your own text, you can only tell that because most people asking something which they don't know and get some answers, because the large language models are able to formulate it in such a convincing way, they might believe it. And to tell hallucinations apart from real knowledge is really hard. Let me give you a small example. So everybody has heard of these déjà vu effects, right? Even in the human brain, you sometimes think, I think the facts were like this, or this happened like this. Because in the brain also, similar episodes are either saved next to each other or encoded in a similar way. We as humans also can have hallucinations by making up things or thinking that's the reality, but it was not.
Yeah, so true. What can we do against hallucinations then? Like, is there a way to stop a model from having hallucinations so much?
Yeah, the only way is adding more training data, or as you see in retrieval augmented generation, providing more context info so that the network has more real facts to cling to. You have to imagine that or know that large language model is a statistical model. So you give it a sequence of words and it creates, based on its own statistic, another sequence of words. If you provide the right sequence of words, which are the facts, then the model will hallucinate less and statistically create the better response based on the input.
Okay, so how often we have hallucinations also depends on like the amount of training data, the size of the model, and stuff like that.
Yeah, the size of the model definitely can incorporate more training data. Smaller models hallucinate more because they cannot save the amount of data. But yeah, right. I don't think you can prevent hallucinations 100%. And that is also the challenge for us if you want to create products, to create measures, to create algorithms in order to restrict hallucinations as well as possible.
True. Yeah, thank you so much. I think that were the questions from the chat. If no one else has a question, I would say thank you for being here. Thank you for explaining this to us and for this great session. And yeah, I'm going to share the validation tutorial so that everyone can take the validation tutorial and earn the points for the contest. I just put it in the chat. I'm also going to put it in the description. And I think you were going to share the notebook. I'm going to share it in our SAP samples repository and also add that link to the description later so everyone can try it out. Does that sound good? Cool. Then I'm going to end the stream. Thank you so much. And I'm hopefully going to see all of you later in the AI ethics session at 4 o'clock.
Thank you and bye.